Welcome everyone. Today we are going to be learning about contaminated sites and how we clean up contaminated sites. You're going to get to learn about different types of contaminated sites in water, soil, air, and ultimately learn how we can use various remediation methods to clean up your very own oil spill. So let's get into it. I first want to give some recognition to our team that developed this lab. And so I had the great fortune to work with Ali Sack, who was a college mentor, and we put this lab together to really help engineers, future engineers, understand the potential opportunities and career opportunities when it comes to contaminated sites. Let me tell you a little bit about myself. My name is Carla McQuarrie and I come from Nova Scotia, Canada, and I am so excited to be bringing this particular lab to you. I have been an environmental engineer for 30 years now, and I started out with a 5-year engineering degree here in Canada, and then I followed up with a Master's of Applied Science degree. And so I have worked on contaminated sites from literally the East Coast all the way to the West Coast of Canada. And after working for a couple of years, I decided to go back and get my Master's of Applied Science, and this was through a research grant. And when that, I was working specifically in water quality. I can tell you I knew from a very young age that I wanted to be an engineer and working in water. So I had the opportunity in grade 6 or 7 to do a field trip. And with this particular field trip, we visited a salmon farm. And I knew then and there that I wanted to work with water and find ways to make water cleaner for the environment, for fish. And that is what I've spent my entire career doing. I didn't know at that time that it was called an environmental engineer, but as I went through high school, I had the chance to learn different subjects that really started to point me to engineering as a career choice. And the picture that you see up on here on the screen is a contaminated site that I worked on way up in the north of Canada. And I always love to show people this site because when they look at it, they might think, oh yeah, it's pretty obvious why an environmental engineer would work here at a big site like this. But I want to make sure you understand some of the exposure to all the different types of engineering. I work at this site with so many hundreds of different types of engineers. So for example, civil engineers, they help us make sure that the water is moving around the site and that all the ditches have been properly formed so that we can move water from any area on the site to that big pit that you see in the middle. That is where we collect all the contaminated water. And just like in the lab that you're going to do today, when you have contaminated water and you have to clean it up, we don't want to have to move it all around. We want to try to contain it to one area. We have mechanical engineers, and they help us size the pumps that we're going to use when we move the water. And once the water goes underground, we have to pump it out, and we have pumps absolutely everywhere. Then we have electrical engineers that help us make sure that we have power where we need those pumps and wherever we need power around the site. We work with structural engineers to design the buildings that all of these pumps are housed in. We work with geotechnical engineers that help us determine the slope stability and make sure that all of the areas that are containing water or containing tailings are safe. And these are just a small sampling of the different types of engineers we work with. And I want to just present to you that engineering is not just one specialty. Even if I was a civil engineer, if I were to bring a highway civil engineer to the site and bring them to the site to design these ditches, they wouldn't really know what they're doing. Throughout your career, you're going to learn your material, and then you start to develop specialties. And you develop areas that you figure how your career is going to develop in a certain path. And then when you find an area that you really love, it can be one little slice of the whole spectrum of engineering. So let's jump into it and talk a little bit about contaminated sites and remediation and why we even need remediation. You've probably heard about big oil spills in the ocean. You've heard about drinking water becoming unsafe because of chemicals. And you're hearing about fish even becoming unsafe because we have a whole food chain that get impacted when there's toxins in our food supply. So at the very bottom of our food chain, as they start to migrate up, if there's any chemicals that actually bioaccumulate, and that means that they accumulate in the body because they're persistent chemicals, then they can start at the very bottom of the food chain and work their way all the way up to us as humans. Another example is coal ash running off of a power plant. This could be where we have refineries. There's other sites like dry cleaning operations, power plants, gas stations, companies that produce chemicals. These are all different areas where we could have sites that end up being contaminated. So let's dig a little bit more into the contaminated water issue. And you may have heard a little bit about this in the news lately. Almost half of the tap water in the United States is contaminated with chemicals known as forever chemicals, and that's according to a study from the U.S. Geological Survey. The number of people drinking contaminated water may be even higher than what the study found because the researchers were not able to test for all these per and polyfluorinated alkyl substances, or PFAS chemicals that you may have heard it being described, and they are considered dangerous to human health. There are more than 12,000 types of PFAS according to the National Institute of Health. And if you're looking for something fun, there's a really great database called the Environmental Working Group, EWG.org. And I would really recommend that you go in there, put in your zip code, and you can actually look up the performance of the water treatment systems that fall within your own zip code and understand how they are performing for your local community. So with any problem that engineers are tasked with solving, it's really important to understand who it's impacting. And when we watch this short video, I want you to be thinking about what was the problem here and who was affected by that problem and who benefited from the solution. And then start to think about how engineering could have been involved in the solution. So let's take a look.
Leadville, Colorado is home to a nationally recognized recreational trail, a gold medal trout fishing stream, and a $1.1 million sports complex. However, these amenities were not always part of Leadville's landscape. The town was part of an 18 square mile area of hazardous waste contamination. A legacy of 140 years of mining activities contaminated soil, surface water, and sediments with heavy metals. High lead levels posed risks in residential and commercial areas. Children in particular were at risk for elevated blood lead levels. The environment suffered as well, with acid mine drainage taking a heavy toll on the Arkansas River, destroying native vegetation and wildlife habitat, and threatening downstream water supplies for recreation, livestock, irrigation, and public drinking. The threat to human health and the environment led EPA to designate the area as the California Gulch Superfund site in 1983. Cleanup activities have made large portions of the site safe for reuse, allowing Leadville to reimagine its future. The community came together to transform a portion of the site into a recreational sports complex, amenities the community had never had before. Across the country, EPA's Superfund cleanup activities have helped pave the way for communities to reclaim and safely reuse Superfund sites.
Back in 2004, a number of people in the community felt a frustration that we lacked a community park or a community field for our kids. Although the field is the legacy here, the process as well was something that we truly cherish because it involved every public agency, every possible nonprofit on the Front Range and locally to support, and as well as the people of Leadville. Since the completion of the field, it has just transformed what's possible in Lake County and in Leadville in terms of recreation, in terms of family time together. And those are the things that truly warm my heart after all these years and after all that hard work, is just to come out here and see how we turned something that was desolate and barren into something that's just truly wonderful for the community of Leadville.
Today, the Lake County Community Park and Sports Complex is just one of Leadville's many recreational venues. The revitalized Arkansas River is a gold medal stream providing top-notch trout fishing. The Mineral Belt Trail loops through the historic mining district, providing breathtaking scenery and recreation opportunities for every season. Across the country, EPA's Superfund cleanup activities have helped pave the way for communities to reclaim and safely reuse Superfund sites. Superfund cleanups at hazardous waste sites are making a visible difference in the well-being and economic vitality of communities across the country.
Okay, so you heard a little bit about the Superfund program. Let's talk a little bit more about that. It has really helped pave the way for communities to be able to reclaim and safely reuse sites. And the Superfund process is very similar to the standard process for dealing with contaminated sites. And this process kicks in when the owner of a site doesn't have the capability to clean it up. Maybe they're lacking money, maybe the company went bankrupt, maybe the site has been orphaned and they're not sure who owns the site or who is responsible. So in this case, it's a multi-step process, and you're going to notice the cycle is very similar to the typical engineering design cycle. And over the next couple of weeks, that's what you're going to be doing, is applying each step of this process to your simulated oil spill contaminated site. You can see through this process that there is an initial identification of the site, and then they evaluate it. And they put a priority on it, and that's called the NPL listing, the National Priorities List. This is the piece that's a little bit different than the typical remediation process. It's specific to the Superfund process. From here, we move into engineers and the environmental scientists working together to come up with a feasibility study, really assessing the site and making sure that they understand all the nuances with it. And then they design a plan and an action plan to clean up the site. And they work to make sure that it stays within their design costs and their schedule constraints. And then they have to look at it over the long term to make sure that it's working as it's supposed to. So that's called the long-term monitoring. Okay, so let's get into contaminated sites specifically. What are they and how do they get cleaned up? So by definition, a contaminated site is an area of land that has harmful substances in the soil, the water, or the air, and very typically because of human activities. These substances can be chemicals, heavy metals, or other pollutants that pose a risk to the environment and the human health. They often result from industrial activities, improper waste disposal, or sometimes accidents or natural disasters. So cleaning up these sites is the process known as remediation, and that is what we do to make the land safe again for the people and the wildlife. So there's not just one type of contaminated site, but really a wide variety that are both on land or in bodies of water. So just a few of them, for example, you'll be very familiar with: landfills. Right? So with a landfill, leachate is generated by the decomposition of waste, which can then leach into the soil and the nearby water. So that's when the water, rain is coming through the landfill, and then we create a leachate. In today's environment, landfills are designed with a lot of containment and a lot of protection, but the older landfills do not always have that. Then we have ocean or bodies of water. So we can have oil spills that occur that are very detrimental to the environment and wildlife, and they can happen by accidental or sometimes intentional chemical spills. Mining operations. Abandoned mines often contain unmined mineral deposits, mine dumps, and leftover materials that contaminate the surrounding water and ecosystem. So this is a really big one, especially with legacy mines. Back when there was a lot of mines very active in the 1960s, 70s, 80s even, they were not necessarily aware of some of the environmental impacts that they were having. And so nowadays, when a mine opens up, it actually has to put the money aside and develop a closure plan before it can even get the approvals or the permits to open. And so when we have a mine, we need to make sure that there's going to be sufficient funding to properly close it and make sure that we aren't left dealing with a legacy of abandoned mines. And lastly, industrial and power facilities. Industrial facilities often store a lot of hazardous materials, and they can be sometimes in underground storage tanks that sometimes will fail, and that can result in contamination of soil or the water. Sometimes it's simply the manufacturing processes and how things have typically been done. So when we look at the types of contaminants, they can kind of be broken down into two categories, either persistent contaminants or non-persistent, and they have different severity levels. So a persistent contaminant is one that can build up and accumulate in the food chain, and it has a much longer negative impact. And some typical contaminants for water would include aluminum, arsenic, cadmium, chromium, chlorine, fluoride, microorganisms, or lead. And you've probably heard about lead, for example, leaching out of older plumbing systems. And this is really important, especially for potable water. So potable water refers to the water that we drink. And so it has a higher quality standard. And more recently, we've been hearing a lot about microplastics and how they can build up in the food chain. These same chemicals and contaminants can also exist in the soil, but you also have things like pesticides, fertilizers, petroleum hydrocarbons, maybe if it's been a leaking tank. Sometimes we have asbestos, heavy metals. And the way that we approach these different contaminants and contaminated sites depends on the location and the source of the contaminant. So how are these sites? We're going to talk about how we go from a contaminated site and into the remediation process. And like we mentioned, remediation is that process of cleaning up the site to make it safe for the receptors. Okay, so receptors are the humans or the animals and the environment itself that are impacted by the toxins. So as an engineer, you have to consider a lot of different things for the remediation, and we're going to talk about those. You have to consider, what is the media? Okay, so the media is either the soil, is it water, is it air? And are there any other special considerations? Like, for example, is it a remediation in the middle of New York City? That's going to have very different considerations than a remediation in a remote site in the north. So, for example, traffic and making sure that the site is protected from people that might be walking by. Maybe there's human homes in a lot of neighborhoods. There's children playing in the area. So these are all things that have to be considered as part of the remediation plan. And let's talk about some of the different technologies that are available right now. And this is not the only list, but what is so cool, because we know with engineering that things are constantly evolving, right? Engineering is all about solving problems. And so that is what drives research. And I love the fact that universities are instrumental in advancing new remediation technologies. There's a lot of great universities that are doing remediation on, or research on all of these different remediation techniques. The first one that we call excavation often is called dig and dump. So in the field, it's called a dig and dump, where basically we excavate the contaminated soil, we dig it out, and we dump it somewhere else. We take it somewhere else to be treated. And so typically you're taking it from an area where it has a receptor to an area where it doesn't have. So maybe you take it out of the ground and then you take it to a land farm that has a lot of containment and it can be properly treated. It's a very rudimentary technique, but it is very effective and also very popular. It's primarily going to work for things like hydrocarbons, so the fuel spills, but it's not going to work with some of your more persistent chemicals that are going to require a much more complicated remediation technologies. The next remediation technique we're going to look at is dredging. And that's basically the same thing as a dig and dump, except that it's underwater. And so when you go to the ocean and you're digging up the contaminated soil that is on the bottom of the ocean or the bottom of a lake or a river or a stream bed, that is called dredging. So they dredge it up and then basically take it off-site and use that dig and dump approach. Now, with bioremediation, we're starting to get into some of the more cooler technology. So bioremediation just essentially refers to using organisms that already exist in the earth, and we leverage these microorganisms to help them break down things faster. So we take enzymes and catalysts, and we take processes that exist in nature and just encourage them to happen a little bit faster. Pump and treat, another technology, is where we pump water out of the ground and we build what is called an extraction well, or maybe an interception trench in the ground, so the water all gets collected underground. We pump it out, we treat it, and then we allow it to go back into the earth, via a stream or some other water body. Solidification is also known as stabilization, and this is where we actually add something to a contaminated area to make it more stable. And so one example would be concrete. So we might have contaminated soil that we mix with cement, and that will end up creating a concrete, and then it is locked in there. So it's no longer a risk or to the various receptors. But it's somewhat temporary because we don't necessarily know the impact in 100 years from now when that concrete may start to break down. And the last one we'll talk about, but certainly not the last of all the available technologies, is soil vapor extraction. And this is when you're trying to purify the soil in the groundwater. You inject air into the ground, and that creates a vapor, which we then, with the moisture, whatever contaminant is in the ground, and then you treat that vapor, and that's how you remediate the site. So when you're determining which remediation methods you're going to use, you really have to understand the type of contaminant. You can't apply the same technique to any contaminant because they don't all behave the same way. And so that's where the engineers and scientists have to really work together to understand the behavior of the contaminant. And also the media that you're trying to clean up. Is it water? Is it soil? Is it air? Or is it a combination of all these things? And then lastly, the site. That is so critical, is understanding the land use. So for example, the criteria that we're going to set for a industrial site is going to be very different than a contaminated site that may be nearby where children play. Because all of those receptors, remember the receptors are the humans or animals that are using the sites, they could be animals or they could be humans. And when you have, for example, a child as a receptor, they have a different toxicity levels that they can tolerate because their metabolism is different, their blood volume is smaller. And so when they're exposed to the same amount of chemical or a toxin as an adult, it has a bigger impact or a greater toxicity. And so when we go through a process, it's called toxicity assessments, where we have to understand who are the receptors on the sites and how are the different toxins going to actually impact them. And they may consider things like, for example, will a child be here for 2 hours? Will a child be here for 4 hours or more than 8 hours? And it becomes a very detailed scientific assessment. And biologists are actually very critical in this process. And not every remediation technique is going to be used at every site. So for a site that has an oil or a petroleum impacts, you are not going to be able to use all different types of technologies. You have to also consider what is the intended goal for the site or the long-term land use. Is the site just to go back to steady state because it's going to still be an industrial site? Or are you maybe trying to clean up the site to make it a future development for the future? Maybe it's going to become a playground, or maybe it's going to become a parking lot. So understanding the future land use is really critical to a remediation process. I thought it might be interesting for you to get to see the different kinds of personnel that get involved on remediation, not just during the remediation process, but also as part of the emergency response. So as you watch this video, take a look at some of the different players that you might be surprised about and the various jobs that are available at, for example, the Environmental Protection Agency.
Sources say the rig collapsed early this morning. Several fires have already broken out.
Looking like it will be a Category 4 when it makes landfall.
There's really no knowing how long it might burn.
Predicting swells between 8 and 10 feet high.
Dieron aviso de un tornado que arrasó.
Officials are encouraging locals to evacuate.
Pollution remains one of the greatest dangers to our future.
We haven't yet been able to contain the wildfire. We expect it to spread.
And I think the real question here is, who's going to do something about it? Inbound or rendezvous point. Found him, Ruby. We found him. Peeling off.
So I found some of those jobs so fascinating, and I think it really can open up your eyes to understand that there's lots of different ways that you can become involved in the response process. But now let's talk a little bit about engineering process. Have you ever seen this engineering design cycle? It is a typical engineering process that we go through no matter what type of engineering. And so we start with the learning, understanding, and in this case, so we're understanding the site. Then we do the design, thinking about how we're going to approach the remediation. Then we actually construct it. We test it out. We make sure that it's working. And then we are constantly learning. So maybe there's things that we have to tweak throughout the process. This is the same problem-solving process that engineers use all the time when tackling any complex problem. And I just want you to understand that the remediation is in essence the same exact process. So you can see that the learning is the first phase of the engineering design process, where you start the first few steps. You're trying to get a sense of the site, where it's located, what kind of hazards are there, what are the impacts to the community. And that's going to be the first part of this challenge. Once you've assessed the site and you've kind of created the scenario for your site, and when you're going through this with your own, we want you to be creative. Think about what are some of the unique features of your site, and you can make this up as part of your remediation plan. Each team should be creative and come up with their own scenario for the oil spill. And then you're going to work with coming up with a plan. What type of technologies do you want to use? What resources? And we're going to talk in a minute about some of the techniques that you can use for your specific oil spills and coming up with your own action plan. But keep in mind, you're going to have to consider things like cost and time for cleaning up your site. And we're going to give you some guidance there. So we want you to prioritize the different things and look forward to hearing how you're going to approach this. Ultimately, you're going to clean up your site, and then in the real world, the long-term monitoring would kick in. That's where you start your actual monitoring to see how well did it work. Okay, for your lab activity, we're going to be looking at a specific type of contaminated site. It's an oil spill in the ocean. So an oil spill can be a minor spill, where maybe it's just from a boat that's leaking, or maybe it's a major one from a major pipe break. So we want you to think about this and what are some of the impacts that you might start to see from an oil spill. We have wildlife and we have fish. We talked about the food chain. So the oil spill can actually affect the bird, but then the whole wildlife, like our coral reefs, can also be impacted. And if a coral reef is shallow enough and it starts to be impacted by the oil, you can literally kill an entire coral reef because it gets suffocated. And we know that the critical role that coral reefs play in our whole ecosystem. So it's really critical that we take rapid action when we have an oil spill in a water body. So there's a couple of different ways to remediate oil out of water. And for example, we'll talk about some of these techniques. So the first one that we're going to look at is a boom. And a boom is a floating physical barrier. And when you have a spill, one of the first things you want to do is take immediate action to try to contain it as much as you can. We saw the EPA. These are the type of emergency response. You want to limit it from spreading. So when you start with your contaminated site, you want to be thinking about how can you keep that oil all together. And that's where a boom comes in place. Next, you have things like called absorbents. And these are materials that are going to help absorb the oil off of the surface. Next, you have skimmers, and these are boats that are going to come in and try to skim the oil off of the top of the surface. In your lab, you're going to be using spoons to act as skimmers. And lastly, the dispersants. These are added to the water to help break the oil up to make it easier to remove. So all of this, you really need to understand the chemistry behind the oil spill. We know that oil, it floats because it's less dense than water. And you probably also know that oil is hydrophobic. So that means it does not mix with water. And then you also have to consider the polarity. So you've got to be considering all of that chemistry. And that's what the engineers have to think about when they're trying to harness the best tools to come up and remediate their site. Now, we're going to be looking at this video in your workbook, and it is a really key piece of understanding how the earth essentially takes care of itself, which is bioremediation. So some microorganisms can actually eat a contaminant and then it ends up getting removed from the ecosystem. And the advantages of bioremediation is that they are a natural process, so they can be a little bit cheaper, but they're also much more time consuming. It can be a very slow and long process.
Our Earth faces many problems. One of these is how to deal with the dangerous chemicals we produce. But microbes can help us. Bioremediation is the process of using microorganisms to remove or degrade pollutants from the environment. Under the umbrella of bioremediation are different techniques. Confused? Here's an example. Let's look at oil spills. They're huge environmental disasters that we don't really have a viable solution for. They cause such damage to the environment because petroleum is a toxic mix of organic compounds, heavy metals, and hydrocarbons. Add to that rapid dispersal and the breakdown into even more damaging secondary chemicals, and you have a disaster that can cause serious acute and long-term effects. So how can microbes be used to prevent the damage caused? Well, certain microorganisms like Marinobacter are known to break down the harmful chemicals into safer, non-toxic compounds. If left to their own devices, the microbes in the environment would eventually break down the oil. It would just take a long time, as they generally only account for about 1% of the marine microbiome. Microbes are limited from growing into huge numbers by the availability of nutrients and other factors in their environment. The addition of, for example, fertilizer, which contains nitrogen, can remove these limitations, allowing the microbes to increase in numbers and speed up the breakdown. As well as oil spills, bioremediation techniques can be used to clean up acidic mining damage, soils contaminated by heavy metals, and plastic pollution. At the moment, bioremediation techniques are slow, but with more research, it is hoped that we can optimize the techniques and make bioremediation the quickest, most sustainable way to make our planet cleaner.
Okay, so for your lab activity, this is what your kit is going to look like. And this is some of the equipment that we have put together for you to create your very own contaminated site. But we want you to be thinking about the scenario. So first, let's go through these items. You've got your container. So this is going to be your pan. And just a little tip, whenever you're moving your pan around, if you're going to be moving it with the water, make sure you have some kind of a base underneath of it, or be using it on the area where you can dump it out easily at the end. You're going to be modeling the oil spill using the oil and the sugar, and you're going to mix those together and then look at some of the impacts of that oil spill. You're going to, for example, use a feather to really understand and see firsthand the impact on that feather when it goes into just water versus when it goes into the oil. So you can imagine if you had a duck that is swimming in the water all day long versus a duck going into water that has been impacted with an oil contamination. So you're going to have these tools, and as example, popsicle sticks, straws, they may be your best bet for coming up with a boom. You have your spoon, so that's going to be your skimmer, but you can also use your pipette for that. You're going to have some absorbent materials as part of your kit, but really I encourage you to be creative and look around you and test different things out. Think about some things you may have at home that you want to test and that you could be using as absorbents, or maybe around your classroom. The key is to try and see things and share that information with your fellow classmates. And lastly is going to be the dispersants. So you're going to have some soap that you can use it as a dispersant, and you're going to choose that as part of your remediation plan. So we'll go through these steps, but all the details are in your workbook. So essentially you're going to create your body of water in your pan. Then you're going to create your contaminant by combining the oil and the sugar, and then you're going to contaminate that site by pouring the oil and sugar mixture into your pan. But this is where it's going to get really fun, because developing what your remediation plan looks like. We don't want everyone to do the exact same thing. So we want you to sit down with your team and come up with some cool scenario as to what really happened here. Like, paint a picture. How did this site get contaminated? And what are some of the other factors that you want to have specifically for your site? Is it a really windy area? Is it an area where there's, people launching boats maybe? Or is it in the middle of an ocean? Is there children coming to play in this area? All these factors, you can come up with your very own contaminated site and then use that when you're choosing some of your technologies that you're going to use to remediate it. Maybe things like, are there any species at risk that you have to be thinking about? Are there deer that maybe come and feed out of this pond? So give us some details and be really creative about what your site looks like and why, and some of the things you're thinking about with your remediation. Highly recommend that you come up with some sketches, and you're going to want to think about those technologies, but not only which technologies, but the cost associated with them. You can't just do everything that you want to do, because you'd end up blowing your budget. And now you're going to go through all the steps in your workbook, but really pay attention at step 6, because this is after you've completed your mixture. You want to pour that water and oil mixture back into the measuring cup and try to measure the amount of water and oil that remains after you've gone through your remediation. And this is going to give you an idea of how effective your initial remediation was. And then what we're going to do is take the remainder of your contaminated water and we're going to add yeast to that mixture to simulate what a bioremediation might look like and see how you can remove some of the sugar from your system as well. So you'll be going through these various steps to actually blow up your balloon, which is part of your bioremediation process. Okay, so things to consider when carrying out remediation. I'm sorry if I sound like a broken record, but we really want you to be creative and think like an engineer. Brainstorm with your group and make this as realistic as possible. Not just your simulation, but also your remediation plan. You want to paint a picture as much as you can of what your site looks like and all the different factors that you considered. But I also want you to be thinking about scaling this up. How would this apply to the real world? Like imagine taking your scenario and scaling it up by 100 times or 1,000 times or 1,000,000 times. Could it still work in real life? And so be thinking about some of the limitations of the different technologies as you would apply this in the real world. And also, when you're going through this, be thinking about all the different types of engineers that could be involved in this process. And not only engineers, but also other types of professions. So for example, there could be business people. When you have a contaminated site that maybe isn't funded through the Superfund, you actually have to develop a business case for remediating that site. So you have business people, you have project managers, you have scientists, you have lots of different construction operator, heavy equipment operators, you have people that are developing the maps. It is so many different career paths that can be involved in environmental remediation. And highly encourage you to be thinking about which area of this could you really be interested in. Maybe, for example, you're very interested in the electrical side and how an electrical engineer could actually be involved in environmental remediations. So there is no limit to the different types of combinations that you can have of professions. And what I highly encourage you to do is be thinking about what are you really interested in and then figuring out, kind of reverse engineer it to say, what types of engineering could I get involved with that still allows me to be working in an area that I'm really passionate about? You saw how I was able to achieve that with my career. I wanted to work with water and keeping water clean, and I was able to find a career path through engineering that allowed me to do that for 30 years. Okay, Engineering Tomorrow offers a lot of different opportunities to explore various types of engineering. And so if you liked today's breakout, you may be interested in other areas of research that you can explore yourself, like oil spills, bioremediation, pollution, water treatment, lots of different areas for you to dig in and do some research on your own. And the types of engineering that are relevant to this particular breakout are environmental engineering, chemical engineering, health and safety engineering, mechanical engineer. But also, Engineering Tomorrow offers so many incredible labs that you can try different labs. For example, our water treatment lab, which is a really great continuation when we look at how we're treating and cleaning up water as well. So good luck with your projects and can't wait to hear your results.